Okay, let's dive right into this. Welcome to today's Explainer. Today, we're unpacking a massive challenge in our modern digital era: algorithm validation. How do we actually prove that an automated system does what it claims to do? We're going to trace this really fascinating journey, starting from the hard, numbers-driven world of financial forecasting, and then taking those exact foundational concepts straight into the cutting-edge realm of modern AI transparency. So it's a wild ride from spreadsheets to neural networks. Let's get to it. Here's our roadmap for today. First, the algorithmic trust problem. Second, financial diagnosis through backtesting. Third, the AI transparency imperative. Fourth, explainable versus interpretable AI. Fifth, the transparency toolkit. And finally, number 6, governing the future.
All right, kicking things off with Section 1, the algorithmic trust problem. So as we lean more and more on automated systems to crunch data and make predictions, a huge question pops up. If an algorithm is making a high-stakes decision about your finances or your career or even your health, how do you actually know it's correct? Like, how do you prove it? When we hand over this much responsibility to a machine, we can't just cross our fingers and hope for the best, right? We need rock-solid proof of safety and performance. Let's look at how the early quantitative pioneers tackled this.
Let's move to Section 2 and see how this builds: financial diagnosis through backtesting. Long before anyone was chatting about large language models, the financial sector had to build a really rigorous framework to solve this exact trust issue. I absolutely love this analogy from a 2023 study by researchers Yildirim and Centaur. They put it like this: backtesting would be an example of a situation that allows the doctor to have an idea of the diagnosis by questioning the patient's history of the disease. And this brilliantly illustrates what backtesting actually is. It's exactly like a medical diagnosis. A doctor looks at your medical history to figure out what's wrong today, right? Well, financial analysts use historical market data to diagnose the validity of a trading strategy. They toss their algorithm into the past just to see if it would have survived.
When they look backward at these strategies, the finance world relies on some very specific metrics. We're talking the Sharpe ratio, maximum drawdown, profit factor, volatility, and the total number of trades. But here's the absolute most important takeaway from the researchers. You literally cannot look at these in a vacuum. Because the criteria change from strategy to strategy, these metrics absolutely have to be evaluated together to get a true read on retrospective performance and to estimate profitability with the lowest possible risk.
And to prove this, the researchers didn't just play around with theoretical, made-up data. No way! They actively tested a simple trading strategy against the historical data of major real-world shares: Apple, Amazon, the SPY ETF, and Google. By applying their strategy to these real markets, they mathematically measured those retrospective metrics. It proved that numerical validation on historical data is absolutely foundational to trusting any system.
Which brings us perfectly to Section 3. The AI transparency imperative.
Now, as we make the leap to complex neural networks, the whole game changes. We have to pivot away from just the pure math of finance into a much deeper, holistic validation for modern AI. It's not just about the numbers adding up anymore, it's about how the system actually learns and behaves. Check this out. 65%. That's right, 65% of customer experience leaders now view AI transparency as a core strategic imperative for trust. This is no longer just some compliance box for IT to check. If your stakeholders don't understand the why behind your AI's decisions, they simply are not going to trust it, period.
And the business stakes here? They are incredibly high. Fully 75% of businesses are afraid that a lack of transparency will literally increase customer churn. Let that sink in for a second. You could lose customers simply because your AI is acting like a black box. This proves transparency is a boardroom issue, for sure. It hits the bottom line directly.
So the crucial point is that regulators aren't just sitting by, they're stepping in to mandate this trust. Enter the EU AI Act. This is the first comprehensive AI regulatory framework of its kind, and it has literally turned transparency into hard legal compliance. It introduces incredibly strict documentation rules for general-purpose AI, meaning developers have to expose their training methods. And for high-risk systems, stuff like hiring or healthcare, the law actually mandates that users are given enough info to properly interpret the AI's output.
Moving on to Section 4, explainable versus interpretable AI.
Now, what's really interesting here is how we navigate these new rules. We absolutely have to get our vocabulary straight because people mix these two terms up all the time. Explainability is all about the why. It answers why the model produced a specific output, like why did this specific person get denied a loan? Interpretability, on the flip side, is about the how. It actually exposes the inner workings of the AI itself, answering how the model operates internally and tracing its logic layer by layer.
If we dig a bit deeper into explainable AI, or XAI, this is the tech that translates all those crazy complex internal computations into human-readable reasoning. And to pull this off properly, organizations actually need two things. They need local explainability, which explains a single individual prediction for the end user, but they also need global explainability, which maps out the model's overall behavior across all the training data. You need both to satisfy everyday users and the system auditors, making sure there isn't some massive bias baked in.
All right, Section 5, the Transparency Toolkit.
So how do we actually pull this off in the real world? Let's shift gears to the operational side of things. If you want a genuinely transparent AI program in production, you fundamentally need a pipeline with three core artifacts: model cards, data sheets, and audit logs. Every single model needs these three steps documented, and they have to live right alongside the model in a central registry. That way, if anyone audits the system, they can easily piece together exactly how it was built.
Let's unpack what actually goes into these. Model cards, that's your minimum viable product. They have to list the intended use, known limitations, and evaluation metrics. Data sheets are all about provenance. Where did the data come from? How was it sampled? And what are the known population biases? You got to list those out. Finally, auto logs. These are your mechanical backbone. They map out every single decision by recording the model version, the inputs, and the exact confidence level for highest stakes decisions. Because remember, undocumented artifacts literally cannot be audited. If you're missing data sheets, that's a massive, tangible risk to the business.
And that brings us to our final part, Section 6, Governing the Future.
Look, having the toolkit is great, but how do you actually enforce this stuff every single day? That's where effective AI governance comes in. You need a cross-functional committee. We're talking folks from engineering, legal, security, and the business side, all reviewing these models. You need automated software deployment checks, so a model physically cannot be pushed to production if it doesn't have its model card attached. Plus, you need predefined incident playbooks ready to roll before an AI failure happens, and really strict contracts for third-party APIs. You definitely don't want to inherit a transparency gap from an outside vendor. Bottom line, transparency has got to survive fast-moving release cycles.
I want to leave you with this final, somewhat provocative thought. If your AI made a decision today, maybe it routed a customer, approved a big transaction, or diagnosed a problem, can you explain exactly why? Like, could you pull the audit log, look at the data sheet, read the model card, and truly understand the logic? Because in today's landscape, from financial backtesting all the way to the EU AI Act, just saying, I don't know, is simply no longer an acceptable answer. Thanks so much for joining me on this explainer. I really hope it helps you build safer, more trustworthy systems.